Okay guys, so to finish up this exploration we did in class, we're just going to do number 5. We're not going to worry about number 6. Okay, so the two equations to complete number 5 are on the top of the assignment, the x of t and the y of t equations. And so this is how we're going to add a parameter into the situation. Okay. As we've talked about, the parameters generally that we add in is time. And the first thing we're going to look at is finding the time it takes the ball to fall to the ground from its maximum height. So we're going to need to know what that maximum height is, which is 90 feet, which is our max height. Okay, since we're talking about the height, we're going to use y of t because in our graph, our y is height. So that's how we know which equation we're going to use. So y of t is as follows. You've got your h sub 0, which is your initial height, plus your initial velocity times the sine times t, and then minus 16t squared. So all we have to do is plug in what we know into that equation. So our initial height, we already identifies as 90 feet. We hadn't discussed yet that at a max or min, the initial velocity, the velocity at a vertex, anybody know what that would be? I'm sure some of you are saying yes. That is 0 feet per second. Okay, so if it talks about the point at the minimum or maximum, it has a 0 velocity, so that would be our initial velocity. And then we're going to multiply that 0 by the sine of the angle we found in number 4, which was 58.4 degrees. So that's the sine of 58.4. And then that's times t minus 16t squared. Well, anything times 0, as you all know, is 0, so that cancels all of that out. And so we're left with our equation of y of t equals 90 minus 16t squared. So now we're just going to solve for t. Subtract 90 from both sides, divide by negative 16, and then square root it. So you get that the t, or time, is 2.3717, and that is seconds. So that just means the ball will hit the ground in approximately 2.37 seconds. Okay, now we have to answer the second question, which is the ball's speed when it hits the ground. So we're going to use, because it's talking about hitting the ground, we know we're talking about our distance this direction. So we're going to use our x of t. Okay. I'm running out of space here, so I'm going to write the equation right here. So our x of t equation, again, I'm getting this from the other page, is our initial velocity times the cosine times t. Okay, and we have to look at what it's asking. It's asking us to find the speed, so that means we are going to be solving for our velocity. So we just plug in what we know. Well, we know over here this is going to be our distance. Well, how much distance are we talking about here? 110 feet. So we plug in 110 for our x of t. We're looking for the initial velocity. We use the same angle, the cosine of 58.4, and then that is multiplied by our t seconds that we got over here, 2.3717. So So we're going to multiply these two, the cosine of 58.4 times 2.3717, and then divide, and when you do that, you get the initial velocity to be 88.96 feet per second. Okay, so it's just knowing what the formulas represent and plugging in the numbers. Now you are doing number 1 and number 2, all of both of them on assignment 6.5.1, and that's due next time. Adios.